Good morning, ladies and gentlemen. As you can see, I'm not here. You have a sub in for me today. So what I'd like to do is I've got a short video here. After the video, you will have some time to work on the worksheet that is due at the end of the day today. So you need to get it done and turned in. The answer key for the worksheet is online in Canvas for you to help you along the way. But this video, I'm going to explain what you need to do combined with what I taught you yesterday in class. You should be able to complete that worksheet and get it turned in before the end of the hour. So, ladies and gentlemen, here we go. Take out your EISNs. Please open them up to slide number 15. If the sub needs to pause the video at any time during this so you can either copy things or so that you can get ready, please do so and then just click play again and it will make up for you to have time to do what you need to do. So take out your computers, open them up. All right. So on slide 15, there are a couple key terms that we are going to define for you. Those key terms, ladies and gentlemen, are isotope and ion. So let's put this up here. I will ask the sub to please pause this, give you a couple of minutes to type this in. If this is already typed into your notes, that's fine. Please let the sub know and the video will continue. Otherwise, pause the video for a few moments to give the students time to copy this down. All right, hopefully you've unpaused the video and you're rolling again. So let's take a look at our definitions, ladies and gentlemen. An ion is a charged particle, an atom that has gained or lost electrons. Now, a particle could be an atom or it could be a group of atoms. We'll talk about that later. And when atoms gain or lose electrons, they gain or lose them in a predictable way. In other words, they always have a certain charge depending on where they are at on the periodic table. Now, we have not gotten to this quite yet. We will get to this next week sometime. But, ladies and gentlemen, these over here are examples of ions. Now, if you're wondering how to make these symbols after the name, the +1, the +2, the -1, the -2, on your keyboard, if you press the Control button and then the period key, it will put you in what is called a superscript mode, which allows you to type those numbers in after and above. That +1, that +2, that -2, and that -1. If you hit Control and the period key again, it will take you out of that mode and you'll be typing normally. So that is how I made those symbols if you are interested in knowing. Now, these symbols up here, ladies and gentlemen, these show an ion. If we just typed Na, that is an atom of sodium. With this +1, this is a sodium ion. Mg is just magnesium. When you put the +2, it becomes a magnesium ion. Oxygen is -2. When you put the -2 up here with not just O, but with the -2, it becomes an ion. So all of these are ions, ladies and gentlemen. And later on, we'll show you how to figure out what kind of ion each atom on the periodic table makes. We defined isotope when we gave you the properties of a neutron. An isotope is atoms that have the same number of protons. If two atoms have the same number of protons, they are the same kind of atom. But the atoms have different amounts of neutrons in their nucleus, different numbers of neutrons in their nucleus. Now remember, neutrons give you special properties, and that's what isotopes are. They are atoms with special properties. We're not going to worry about what those properties are right now, but that is what they are. So down here in the corner, I have three forms of carbon. Carbon 12, carbon 13, and carbon 14. These are three different isotopes of carbon atoms. They are all carbon. Why are they all carbon? Because they all have 6 protons in their nucleus. But this carbon 12 has a mass number of 12. Carbon 13 has a mass number of 13. And carbon 14 has a mass number of 14. Now, as we learned yesterday in class, you can then find the number of neutrons by taking the mass number minus the protons. 12 minus 6 gives us the 6 neutrons here. 13 minus 6 gives us the 7 neutrons here. 14 minus 6 gives us the 8 neutrons here. So that is how we find that. That is what we showed you in class on Thursday. So let's go to our next slide, ladies and gentlemen. All right, so all atoms, every atom on the periodic table starts out neutral. What does that mean? It means that the protons and the electrons in the atom are equal to each other. 6 protons, 6 electrons, neutral atom, no charge. 8 protons, 8 electrons in the atom, neutral atom, no charge. 82 protons, 82 electrons, neutral atom, no charge. So all atoms start out this way. Every atom on the periodic table begins neutral. All atoms except for 8 of them, except for group 18, the elements on the far right-hand side of the periodic table, those being helium, neon, argon, krypton, xenon, radon, and oxygen. Those atoms are neutral and stay neutral. Every other atom on the periodic table starts out neutral but gains or loses electrons. Why are they gaining or losing electrons? They're gaining or losing electrons to do something called becoming stable. Okay, we'll get into that more in the upcoming days. But atoms can gain or lose electrons. Now, certain kind of atoms gain electrons, certain kind of atoms lose electrons. Again, more explanation to come. But if you are going to gain electrons, ladies and gentlemen, that means you're getting more of them, and every electron has a negative charge. So when you gain something that has a negative charge and you started out neutral, you become more negatively charged. You get a negative charge. When you start out neutral, protons equal to electrons, and then you lose electrons, which have a negative charge, you become positive, because you end up with more positive charges than negative charges in the atom. Whichever one there are more of, protons or electrons, that determines the charge. How many more of them there are determines how big the charge is. So if you have more electrons than protons, you will be negative. How big depends on how many more electrons you have. If you have more protons than electrons, you will be positive. How big depends on how many more protons than electrons you have. Now, you can't gain or lose protons. You can only gain or lose electrons. Why? Because they're on the outside of the electron. They are the easiest thing to lose. Also, if you gained or lost protons, you would change the type of atom that is there. We're not talking about doing that. The term for a negatively charged atom is called an ion. An ion is a negatively charged atom. A positively charged atom is called a cation. So a cation has a positive charge, an anion has a negative charge. That is the term used to describe those things. An ion is just any charged atom. An anion is a negatively charged, a cation is a positively charged. How do you become an anion? You gain electrons. How do you become a cation? You lose electrons. Now there is a formula that you can use here. Charge of an atom equals the number of protons minus the number of electrons. We're going to show you that on the next slide. And actually, we're going to rearrange this formula to solve for all 3 of them on the next slide. So I'm going to show you that in just a second. So here we go, ladies and gentlemen. Now, the sub may want to pause this for a minute because up at the top of your slide, it only has this very first formula. You need to type in these next 2 formulas onto your slide before we continue with this part down here. So I'm going to ask the sub to pause the presentation for a minute or 2 to let you copy down these formulas up here. So please pause the video. I'll be back when he resumes it. Okay, so hopefully you've copied these 3 formulas down. Now, we're going to begin here by finding out what symbol, what element has 12 protons. For that, you need your periodic table. The element that has 12 protons on the periodic table is magnesium, symbol Mg. Since you have 12 protons and 10 electrons, we are using the top formula up here. Protons minus electrons. 12 minus 10 will give you a charge of +2. A charge always has a sign to begin it, plus or minus, and then a number. So +2 is your answer, not just 2, +2. For our next one, we have 17 protons. When you look at the periodic table, the element with an atomic number of 17 or 17 protons is chlorine. To find the charge, we take 17 minus 18. 17 minus 18, since we are subtracting a bigger number, we end up with a -1. -1. More electrons than protons, negative charge. For the first one, more protons than electrons, positive charge. Now, what element has 50 protons? That is tin. Tin has 50 protons. Now, I am trying to find the number of electrons. So I need this second formula here. I am going to take the number of protons minus the charge to get the number of electrons. 50 minus 4, a +4, is 46. 50 minus a +4 is 46. That is how we find the number of electrons. If we have 15 protons, your element is phosphorus. If your charge is a -3, now we need to be careful. 15 minus a -3. 15 minus a -3, when we subtract a negative, we add a positive. 15 minus a -3 is 18, because it ends up being 15 plus 3. Now, for these next two, I'm trying to find the number of protons. So we're going to use this formula, the number of electrons plus the charge of the atom. So 2 plus 2 is 4. Now that I know how many protons I have, I can figure out what the symbol is, which is beryllium. So again, I had to find the protons before I could find the symbol here. So if we have 10 electrons and a charge of +3, 10 electrons plus a +3 gives us 13 protons. 13 protons, ladies and gentlemen, is the element aluminum. Okay? So again, these three formulas are going to help you solve these problems. And I give you 2 out of the 3 in each one of these. Now, I technically could give you the symbol, and that would lead you to the number of protons as well, and then you could do the math using those 2 out of 3. You'll see that on the next slide. So it is now your turn to try these. Now, I have put the 3 formulas up at the top again. Okay? So you're going to need to copy those. You can do that in just a minute. Okay? I will have the sub pause it again, and you can do that in just a minute. The one thing I do want to point out is this one right here, xenon, Xe, and this one right here, Pb, lead. I did not give you 2 out of the 3 here. I only gave you 1. Electrons here, charge here. But by giving you the symbol, ladies and gentlemen, you can figure out how many protons there are. So find Xe on your periodic table, figure out how many protons it has. Now you can work this problem. Find Pb on your periodic table, figure out how many protons it has, and now you can work this problem. Please stop the video here. Let them have 5 to 10 minutes to work these out. When everybody seems to be finished, you can put this back on and I will go through the answers again. So please pause the video now, wait for them to finish this, and then I'll go through the answers in just a moment. All right, I'm back, ladies and gentlemen. So here we go. 38 protons means the element is strontium. 38 minus 36 gives us a positive 2 for a charge. 8 protons, 10 electrons. 8 protons means that it is going to be oxygen. 8 minus 10 gives us a charge of negative 2. Again, negative because there are more electrons than there are protons. Positive up here because there were more protons than electrons, positive 2. 6 protons means it has to be carbon. If it has a negative 4 charge, the protons minus the negative 4 charge, if you subtract the negative number, you add it. 6 minus negative 4 is 10. Xenon has 54 protons. 54 electrons and 54 protons means 0 for a charge. So for the next one, it came in at the same time, sorry. 10 electrons plus a charge of positive 3 gives us 13 protons, meaning this element is aluminum. Pb lead, ladies and gentlemen, has 82 protons. When I know the protons, 82 minus a positive 4 charge gives me 78 electrons. 34 minus a negative 2 charge to find the number of electrons gives us 36. The element with 34 protons is selenium, ladies and gentlemen. So the next slide is on the periodic table. We will talk about that on Monday. So with this being completed, ladies and gentlemen, that's your video for today. You can now take out your, or you can now go to the quantifying the atom worksheet. You can complete it. It is due before the end of the day today. I'd like you to get it done before the end of the hour and just turn it in. You have the rest of the hour to work on it. When you're finished, ladies and gentlemen, you can work on something else you need for me, be it a lab that you're missing or something like that. If you're done with everything, the rest of the hour is yours to use as you see fit. Use your time wisely, ladies and gentlemen. Have a great day. Have a great weekend. I will be back on Monday. We will see you then, ladies and gentlemen. Have a good weekend. Goodbye.